Good morning. Thanks very much for coming. It's early morning and it's a bit rainy, but we should be ready to go. I'm Xiaowen Wang. I'm a professor of geography and geographic information science, and also staff here at NCSA. I'm directing the new campus center, CyberGIS Center for Advanced Digital and Spatial Studies. This new Distinguished Speaker Series is sponsored by the center. And today I'm quite honored and pleased to welcome Dr. Bhaduri from Oak Ridge National Lab to give this interesting talk. Not going to repeat the talk. It's quite a pleasure to have Bhaduri here because we've known each other for a number of years, hard to count, as we are all embedded in this broad geospatial information science and technology community. And he received his PhD from Purdue, not too far from here, in the earth sciences. And he went on to Oak Ridge National Lab to have a very distinguished career. And he's leading the geographical information science and technology group there and is a corporate research fellow at Oak Ridge. He has a number of accolades, including one R&D 100 award for his leadership of the Landscan project. Many of you are aware of. He's an expert in population dynamics, emergency response and management. And also recently he picked up interest in urban infrastructure, and he's been also having a lot of influence and activities in transportation infrastructure. He's serving on the Mapping Sciences Committee of the National Academy of Sciences and National Research Council, to just name a few. I think in the interest of time, we need to give the floor to Bhaduri. Thanks very much, Bhaduri.
Thank you, Xiaowen. It's always a pleasure coming back to this beautiful landscape. I thought I had escaped it about 15 years back, but every time I come into Illinois or Indiana, it almost seems like I will be walking into a class again. But it's fun coming here, and thank you, Xiaowen, for the generous introduction and the invitation to come here and talk. What I'm going to do over the next hour is I'll give you a little bit of a background of set the boundary conditions of what this big data, or at least my perspective and version of it, so there is no confusion in terms of what I'm trying to convey. Give you a little bit of examples from our work of what we think we are doing in big data analytics, and then I'll spend the rest half of my presentation talking about where I think are the opportunities and challenges are in dealing with big data analytics across science, including ours in geospatial sciences. So it's a lot of thoughts that it's my personal perspective to instigate some reactions from you. So let me begin with this premise. It's every time there is this discussion about big data, the first thing people ask is, can you define big? And I think the best definition that I have been able to get around is something that is way beyond what you can think about handling today is big for you. So it's the question is ambiguous, and so is the answer, and it's not a one standard that fits all. In this world where we are trying to look for the needle in the haystack, with this, and that's the metaphor we have always used for large-scale data analytics. There is a lot of effort that, as a community, we have spent on defining that needle. And what it's coming as an interesting exercise is to define the haystack. And that's where I think we are Excited and also very uncomfortable because I don't think we have a very good way of defining the haystack yet. But as a research and development community, and that's what we do on a daily basis, we continue to define the needle. That means, what are some of the key challenges that we are trying to address and solve. We are doing novel analytics. That means we are trying to come up with better ways of finding that needle. But when somebody asks me, so what do you do these days? And I said, well, I am into big data. Because, that's the cool thing to say. Who doesn't want to say that you're not into big data? And then the next obvious question is, so what do you do in big data? And my response is, well, I make it. So I add to this problem. So I generate data, and I'm contributing my share to this big challenge. So that's something that we have been doing very, very successfully. So to bring it a little more closer to the world that we live in, and this is something that I have always found intriguing, is how data that is geographic data has sort of driven innovation. And so I'll give you this version that's my personal favorite. That is, back in 1790, when the nation did the first census, marshals on horseback went around and counted about 3.9 million people. And census today, it is still known as the mother of all databases. There is no larger government-held database that we have than the census. The interesting thing happened is about our curiosity. So we were not just happy counting people. So in the next 50, 60 years, we started collecting more and more data about these people that were on there. And some of these terms do not exist anymore. For example, pauperism is not something we would use, and we use poverty. So the interesting challenge came in 1890, because that's when the estimation that how long will it take for people to be on horsebacks and go around the country and count an estimated 65 million people and bring back that information and count it, tally it all up. It was estimated to take more than 10 years. So of course you have a challenge that, by the next 10 years, you got to repeat census by constitution. So necessity is the mother of invention. People started looking for solutions and found this biostatistician in Baltimore who had this very fast counting technology. And you all know about that with the punch card. And interestingly, about 63.5 million people were counted using that technology. And everybody blamed the technology for the missing 1.5 million people. They said, we were sure that there would be 65 million. So there must be something with that machine. But anyway, so just like any other good government effort, the punch card technology was successfully commercialized in 1896. And what is even intriguing is between 1911 and 1924, through 3 mergers, that's evolved into IBM and the beginning of computing. So I always tell people that if there was no geographic data, there would be no computing, right? So make sure you repeat that next time you are in a forum. So let me fast forward. In the GIS world, Tomlinson, who just passed away, 63 is when he comes out and uses the phrase geographic information systems. Late 60s when we start having the commercial GIS worlds. 72 through 85 is when civilian space and commercial defense space is at its peak. We have first Earth observation satellite, and 85, in my opinion, is the tipping point in our civilization when we first got serious about GPS. If you take GPS away today, everything that we do and how we operate is going to go completely. You can live without Google. You cannot live without GPS. I'll make that bold statement, and you can try to prove me wrong. And then, we have been, ever since, after collecting all these data sets from everywhere, And Keyhole came up with this wonderful technology of 3D visualization on a browser. And then Google buys it in 2004 and turns the World Wide Web into the Web Wide World. So now all you need is a browser, and you can probably go anywhere and do it. So the question is, then what are we really trying to do? What is the next thing, what we are trying to do? So I've been thinking about it, and what I have been able to think of it is for the last several years, is that the way we are instrumenting society and infrastructure, our goal is to know everything about everything at all times, except us as an individual. I don't want me in that part, but I want everything about everybody else and everything else at all time in my knowledge base, which is an interesting fact. So a couple of months back, I think this is what was exciting, that you can now have 1080 or 480p HD video collected from space by this small startup, Skybox, out of San Francisco. How many people have seen this before? You can actually order it, and they will sell you 480p HD video from space. It's not about anymore taking pictures. This is commercial. You can buy it. Skybox imaging, and it is phenomenal. It's going to change the way we have always done science and GI science. These companies, two companies, Skybox Imaging and Planet Labs, who are sending this constellation of microsatellites, are going to be changing the way geographic data has always come to us. Okay, let me get out of that and come back to where I was. So if you go out there today and you ask the same question about, what is big data, and you do a web search, right? And I think it's a battle of V's, right? And you have probably seen this. There are these big data supply chains, and I'm showing you not what other people are showing, right? So there is this volume, velocity, variability, and then people have tried to define what these different things are related to, these V's are related to. And there are many nice ways of looking at it. So this is Oracle's version where they added another V, volume, velocity, variety, and then value, okay? And I can understand till that point I'm good. Here is velocity, volume, variety, and veracity, and so there is another V that's been introduced. Data in motion, data at rest, which are the big archives, and data coming in many forms. And these are all. I was completely thrown by this one that I found, that now all of a sudden introduced these two other V's, one of which I have no idea what it means, viscosity. Virality is, I can still kind of grasp my head around that what might virality look like, right? So it's basically getting to, you're trying to be creative is what that comes down to. But what in reality has happened is that, if you think about me, who lives in a DOE national lab world, we are used to the volume issue, okay? The volume issue and the velocity issue are the two things that we have always dealt with. Because to us, data is something that we produce out of our experiments, which comes from either the big computers or a telescope, periscope, a spallation neutron. But it is not really unknown. It is a lot, and it gets produced very fast. But I still do not think that it's part of this unknown world that we are all kind of intrigued with. So if you think about what we are trying to really do with this big data analytics, one is our interest is prediction, right? We love to predict. That's what makes us, special. So can I tell what's about to happen or what is coming, right? That's a very, very powerful thing that everybody wants to do. Or explain something that I have already seen or something that has happened. Is there data that allows me to do that? So those are the two fundamental things. But if this has to work, there has to be a very clear return on investment. If you look at all the success stories out there today for big data analytics, it is either you are giving some new knowledge that you didn't have before, and you're somehow justifying that now I can tell you things that you couldn't have had before from one of those V's, or I'm giving you the same answer, but I'm giving you that same answer faster, or I'm saving you money in the same time, but now you have a little bit of cost savings. And industry responds to that very, very well. That's what the private sector is up to doing today. They're increasing operational efficiency. Like you take Oak Ridge National Lab as an organization of 5,000 people with all kinds of data scientists. Nobody was needed when somebody came in from a private consultant and said, let me show you how you can save by optimizing number of printers you have. And in 2 days, they showed $300,000 worth of saving if we went from anybody buying any kind of printer to X number of printers, and by networking some of these. So they usually looked at the usage of those printers because everything is network. You have those data sets, and they did it. They didn't need us, right? That's what is going on all the time because you have access to that sort of transactional data sets. But when we are looking at really big data analytics to be useful, in my view, the real action is when I can make it meaningful from an individual all the way to an organizational level. That's the value proposition I have to prove. I will also tell you another thing, and I hope to show you one example of it, that if you look at these, so we are in the science world, we are looking at fidelity and accuracy and against volume and resolution of the data, and we all understand that just because you have a lot of data and you keep pumping into your thing, the answer doesn't infinitely get better. At some point of time, it doesn't matter how much more data you have, it doesn't get any better answer, right? But what we are really interested in is that at some level of resolution, do I start seeing something that I did not see before? And that's of interest to me. Also important is if you look at some kind of a behavior that you're interested in and you're trying to understand in terms of a geographic scale. At certain geographic scales, you will start understanding a behavior. And my favorite example is traffic congestion. If you are driving and the guy in front of you or the person in front of you has stopped, you cannot say, I'm in a traffic congestion. Only when you zoom out and you see a whole lot of people having stopped, then you can go to that. So that's sort of the scale issue, geographic scale issue. So big data should work for both big and small science, and that's the other analogy between individuals and organizations. So we are about urban. We are interested in a lot of urban examples, and this is what one of the data sets, an analysis of data sets. This is a recent paper in Environmental Science and Technology, which looked at if you stack people up in very urban areas, you put less pressure on you're not creating new infrastructure. So your return of investments in terms of your climate change, your pollution, that may be you're getting a better return on investment. But what this data showed is that by some people choosing to adopt suburban lifestyle and driving a lot are completely undermining what a whole lot of people are trying to do good for by choosing to live in a big city or in a very urban areas, repopulated. Okay? And we probably wouldn't have understood that so well if we didn't get all the data that is coming together and analyzing it. So this is where we are really trying to focus our next phase of activities at the lab. if you think about energy, which is a very key driver, it's essentially always discussed at a very macro level, although it is driven by micro-level phenomena, right? So we talk about regional energy challenges, regional energy demand, regional energy shortage, national energy shortage, and all that stuff, right? Have you ever talked about your energy challenges? Do you know what your energy demand is? Or shortfall is? Nobody ever talks about it because it doesn't make an impact. The numbers are not very impressive, but what you and I decide to do on an everyday life, going around, doing different kind of activities, ultimately aggregates up to give rise to these complex problems, right? But I will tell you one thing, that if you have to solve those problems, you have to come down to the level of the individuals and make those impacts, right? So that's where the interesting challenge lies. The other thing that we realize that we are essentially about merging networks. We are taking 2 or 3 primary networks and trying to merge them very efficiently. One is our transportation network, and the other one is our energy network, primarily electricity. And we are tying these 2 together with a third and a fourth one, which is cyber and communications. And that communications is, again, driven by people, okay? It's driven by people. If you think about the future, there has to be an optimal, simultaneous optimization amongst our mobility, environment, and energy interests. And if you don't believe me, I'll give you one simple example, right? If you think that energy and climate are the 2 pressing challenges of society, I have a very simple and elegant solution for you. We all stay home. It's going to make an enormous impact. You will have no traffic congestion, minimal emissions. So everything, all we have to do is stay home. How many of you are willing to do that? Right? That's one. Fantastic. Out of, probably 30 people, one. It's not going to add up. It's not going to scale, right? So it's very fascinating that if you look at the people who do this travel behavior research in conjunction with internet and communication technology, and my complete idea was changed when I talked to Patricia Mukhtarian from UC Davis, and she showed me 10 things, of which only 3 supported the fact that now we have all these wonderful technologies. It's actually increasing communications and decreasing travel. The other 7 actually showed how ICT is only increasing travel across the world because we are human beings. We are driven by curiosity. If you show us something, we want to go there. Okay? There are other kinds of interesting complex system phenomena, one of which was work from home in Silicon Valley. And that was supposed to have an incredible impact because now not everybody was driving every day, so you could work from home. And the first indication was, the measured observation was that the traffic was actually lighter on the street, so it was moving a little faster. But when they looked at the data analysis, what they realized is that it was actually having a negative impact because now, all of a sudden, people realized that they could buy the home they always wanted 100 miles out because they have to only come twice a week instead of 5 days a week. So they were driving only 2 days instead of 5, but they're driving more miles than they were driving in 5 days, right? So that was the other kind of an anomaly and fallacy. So what we are really driving for is to create these kind of national scale infrastructure for data simulations and computing where we can understand when we go through this merger of infrastructure, we have a way of observing and monitoring and measuring every phenomena, and then we can do it upstream and downstream from infrastructures so we can actually explain the value proposition, right? So if you today spend $2 million improving a freeway condition, and then the traffic is flowing now 10 minutes faster, right? The challenge is that how do you explain the value to a subway owner 2 miles out? Because he will say, I don't ever get onto that freeway. Why am I paying my taxes to get somebody else go faster, right? And that's where the challenge is. How do you translate these sort of impacts out? Okay, so I will try to get into a little bit of what we are trying to do in this regard. Some of you are already familiar with our work, as Xiaomin mentioned, that one of our key activities is to understand population distribution dynamics across the world. So we do this kilometer resolution data for the world, and then also 90-meter resolution data, time variant data for the 50 states in the US. So we know where people are during the day and during the night. And what we are trying to do now is to take the US resolution data and scale it to the world. So this is the kilometer resolution, and we are trying to go to 90-meter worldwide, right? And the key thing behind that is to understand where are all the settlements people are creating, where are the structures people are creating on the surface. And I will quickly jump through it. Computing is this is where the volume issue we are trying to handle, right? So we can extract at very high precision and accuracy all these settlements that are on there. And now you can have global coverage at half-meter resolution in 4 bands from satellite imaging companies. The question is, can you scale it? Can you handle that kind of a volume to process and extract data information in meaningful states? So the last 10 years, we have seen extremely well output in terms of our algorithms, and the GPUs have changed our game too. So now we can take a city of Addis Ababa, Ethiopia, which is about 800 square kilometers, and extract all settlements from half-meter resolution data in less than 30 seconds. Okay? So we can actually do this for the entire world over and over and still be able to monitor. So the changes in the landscape is something we are very interested in. The other thing that we are trying to do is what else can you monitor? So this is Albuquerque, New Mexico, and this is red, green, and blue is census data about how much money these people make, right? This is block group level data, how much money these people make. If you zoom into these areas, you clearly see a difference in the homes of these people, and this is one of those global phenomena where if you have a little more disposable income, people show the tendency of having a larger home. Okay, very few people. So we are interested in global scale exploitation of this kind of a phenomena, and this is geography, so it's not an universal truth or global truth, but in majority of the places, can you extract these things? And what we are finding is that, this is an example from Damascus, Syria, that they do show very clear distinctions if you can take a number of low-level features into considerations that you are interested in, like how straight are the edges, how much contrast do you have between a building and its background, how wide are the roads. And we are looking at about 180 of these, and this is very similar to how your digital camera puts a green square around a face, right? So it's very similar. But we can, in a very automated fashion, put a qualitative distinction between people's and socioeconomic strengths. And then we are trying to use the other aspect of big data, which is people's pictures people are taking standing on the grounds at this location, to validate, do these look like, rich people's home or middle class homes, or, not so much. The other thing we can do is we can address the velocity issue by putting these kind of analysis on the sensor. So this is the Ohio State campus, and the model is trained to look for small, medium, and large structures. And as the frame rates are being collected, you can see that it's the red, green, and blue are actually showing you what kind of terrain are you flying over. So if that's all you're interested in, you do not need to store all the images that are coming to you. You can only store the trajectories or the information that, how much of what kind am I flying over. And so this has strong applications in disaster response type of areas. Here's another effort that we are pursuing, which is truly a big data kind of exercise, is how much information is out there, and I mean really out there, that you can find through formal and informal sources with browsers, libraries, and everything else, about how many people populate 1,000 square feet of space across the world during night, day, and episodic events. Okay? So we are trying to go out there and collect all kinds of stuff, which is, I will tell you, it is not very elegant in most cases, right? But here is one example that I was going to come back to about, how much would a lot of data would do. So one of the analysts found a schools database for South Africa, which has 14,000 records of schools, very detailed. So the question is to get to the answer, which is, what is my average number of students per 1,000 square feet of school space? Do I really need to go through the entire 14,000? So there was a summer intern from Cal State Pomona, master's student. She came up with this algorithm, and she said, okay, I'm going to do a random draw from this 14,000, and I'll keep churning running average and see at what point of time do I reach the steady state. That it doesn't matter how many more schools I'm picking up, I'm okay, right? And that's what this tool does, is when you come across a very large data sets, but they are all talking about similar things, this has proved to be one of those tools that allows you to, with certain level of confidence, that, look, all you need to do is to look at the first 100 or 200, and then you're okay, right? So not every data sets would do this. So here's what my personal fascination is, that I showed you all this fancy stuff that we can do, right? And I ran into this person, a professor from University of North Georgia, who's helping their local county, Jackson County, which is at the edge of Atlanta. They're a very strongly urbanizing community, creating infrastructure left, right, and center, and they're on the verge of hitting 100,000 population. And that's a magic number for EPA, because the moment you go to 100,000, you have to put a stormwater sewer system. What they're trying to do is, how much concrete and asphalt do I have in a county that allows me to tax it to make this system sustainable, right? So I'm looking for the impervious cover. So to me, this sounds like I'm going to do this for the entire world. But you think about this county guy who is sitting there, he has no idea what data and what algorithm and what magic lies out there to help him do this simple task of creating our society, right? And that is one fundamental thing that changes everything in our country or anywhere in the world, that pouring of concrete and asphalt. The local level zoning, once that is done, everybody else plays around, try to fix the problems. I encourage you to, this is how I started my career at graduate school at Purdue, looking at who makes this decision to put things anywhere. And what I realize is that they are not scientists, but they're very smart people. The only thing that they go by is local economy. If it's good for the local economy, it's going to happen. Unless you can tell them that it's how it's going to flood their own house. Then it's going to change. But we still do not have tools to go out there. And I think that's the opportunity we have as the community to make big data useful for everybody, right? Science should be as simple as taking directions. Today, everyone, you go out there on the streets and ask them if they feel that how much science is there when they take directions. They don't think it. Everybody takes it for granted that you have a smartphone, and it's a built-in feature. You can just tell where you are. You don't have to tell it where you are. It knows where you are, and you just tell it where you want to go, and it gives you the directions, right? And they don't think there is any science, and I think that's how science should work. All the navigational science and everything else, that's what the scientists should do, but the benefits should go down very, very crisply. Okay, so I'm going to speed up here just for the sake of time. Modeling dynamics is very important for us. How people move around, as I said, and there are many ways people are doing it, and I will just show you one way that we are trying to do this, which is you can do this in a model-based format. That is, this is Washington, D.C. every 5 minutes, and you can see the schools build up on the bottom right, followed by the workers. And this is all I'm doing is I'm doing a diurnal variation of population based on activities. How many people work anywhere? How many people come to any place? And how do I understand it over space and time? And that allows me. So this is your energy demand map. Okay, that's how you can think about it. So I'm going to go into in the next set about the challenges that comes in when you start modeling these complex systems and where the big data, the unknown, all these other stuff is doing, right? So this is one of those very interesting, fascinating facts where people dropping off their pets for adoption in these shelters went up significantly in the San Francisco area as the economy took a downturn, right? And it was all well till it was also revealed that these shelters started facing an enormous challenge because they used to depend on donated newspapers for training these puppies. And with the trend of digital adaptation of newspapers, there is an acute shortage of newspapers now, donated newspapers. So which is, again, one of those unforeseen consequences of when you start. But that's what, when you start putting data, more data in, one of the things that you would hopefully get to see is these unforeseen consequences. There is lots of other kinds of data that is out there. I'm showing you one from the Atlantic that I found incredibly fascinating. And this is just data that is being published, but it allows you to ask questions. Can you see the rich and poor or not so rich from phones data sets, right? And iPhones are more expensive. So here is Atlanta. The red is iPhone. The other one is BlackBerry and other stuff. This is Atlanta, Chicago, Houston, LA, New York, Washington. And why do you see this pattern, this distinct difference between red and the non-red, right? It's a fascinating question. So that's the other challenge or the opportunity with big data is it raises questions that you want to explore, okay? But here is Jakarta, Indonesia, where iPhone almost seems non-existent, and everybody's on a BlackBerry. And you ask the question, why? It's almost extinct in our landscape, but Jakarta seems to be doing fine. One of the things that we do for the government is we are producing a number of critical infrastructure data sets for the nation. And I will not go into too much descriptions, but I'll give you one simple examples of these mobile home parks. These mobile home parks that we have all seen is a critical data sets for the entire disaster response community because they're known as the tornado magnets. You ask them, they will say, oh, the tornado magnets, right? Because they get flooded and they get blown out. The nation only had one data set with 24,000 points in it. That's the extent of a spatial data set that there was. So the community's challenge to us was, okay, so you guys are doing all this fancy science of extracting features out of imagery. Can you find all the mobile home parks that we have in the US? Okay? So what we did is we took this National Agricultural Imagery Program data, which is about 22 terabytes of data, aerial collections, 1 meter resolution, never been used other than as an image, as a picture. Okay? We took that and we basically trained it to look for these kind of mobile home parks. And I didn't even know before this that mobile home parks, how different they look from Florida all the way to Oregon. They are very distinct, but you can see one of these things. So we put these on, again, on an automated algorithm to look for them. And in a week, it found 14,000 points in Texas by no human intervention. So we are going and then doing the false positives because it picks up railroad yards and concrete pads and things of that nature. But it's an enormous. So the first ever mobile home parks comprehensive data sets is coming out of processing data that was collected by one federal agency. It is going to be used by the entire federal community. But guess who the biggest benefiter of this work is? Census Bureau. Because by law, they have to find these, and the only way they can find it is pay somebody to drive around, and they get paid by the mile. At the current cost, Census will not be able to repeat that process. So they found a magic in our tool and this kind of approach. And I think that's the opportunity with big data analysis, is that you are making an impact all the way to the national scale. Here is the other one that we worry about, which is the changing face of the nation, which is agriculture or vegetation changing. And the question is, as you are trying to watch your food and energy infrastructure, because we are into biofuels, can you monitor it in real time? We have run this one kind of experiment which won an award for detecting Walmarts. And it's an easy thing to do because Walmarts never take on an existing building, and their footprint are usually very well aligned with the Modi's NDVI 500, 250-meter resolution. And we showed that you can put these automated algorithms on this data, and then it will pick up, give you a saying, I see something changing somewhere, and it was detecting those Walmarts. The advantage is that now we have improved the algorithms and the architectures from taking one single Modi's footprint over Iowa, which has about 23 million time series over 7 years. And the processing on a serial system was 11.5 hours. And you cannot scale that, right? Because if you want to make it operational. So what we have done is we have finally found the sweet spot with a hybrid architecture with MPIs and threads that has shrunk that 11.5 hours to 34 seconds. So as I said, the ROI has to be very important, right? That you are saving time, hence money, and you're making something happen in near real time that you couldn't have achieved earlier. I'll give you one example from the small science. This is a system that we run for the Department of Energy. It's a bioenergy knowledge discovery framework. It has a core database called the Billion Ton Update. Anybody in the bioenergy world, you go and ask them Billion Ton Update, and they all know it. What it does, it allows you to put scenario-driven questions, saying, if I have at $60 a bushel of corn in 2018, where will be people producing corn? So it's tens of millions of dollars of research that produces this database. The state of the art was somebody from DOE will call the program manager, who will call the PI and say, we need this scenario generated. And they will go in with their postdocs, and anywhere from 2 hours to a week, they will create a map. It will come back, and in 2 hours, the question will change, saying, how about $58? And the process repeats, right? What we did is we virtualized this complete applications, including the database. It's not a large database. It only has about 70 million records. But how many PIs do you know who will download a database that has 70 million records? 0. So now they can come to this portal and run this analysis on the fly and get the answers without calling anybody. Okay? So that's big data working for small science. All right, so here is what I'm really going to get you to think. This is all, you all know about these. What I'm really interested in is, from a science perspective, is that can I harvest the crowd for data that is useful for science? Not for finding the cab or having a rental property or anything like that. The science I do on a daily basis, can I get that kind of data from the science, from the crowd? Not crowdsourcing to do my science, like NASA is putting $35,000 whopping dollars for the crowd to give them better algorithm for tracking asteroids. It's on Science or somewhere today, right? $35,000, that's a pretty cheap deal if you ask me, right? How many of you are going to write a proposal for $35,000 to NASA, right? It's a prize, right? Okay, so really the opportunity is, can you replace the survey, which has long been the only and the trusted instrument for science across the board? Can I replace that survey with something else, right? And this is where comes the challenge. And in science, we are driven by average. We all love to create an average representation of everything. And we are looking for this normal distribution to validate and verify that, do I have enough behind my data set, right? This is where the haystack problem comes in, because I do not know what it looks like. So the question really is that, is a 50% non-random sample better than a 5% random sample? Just because you are able to do a bell curve, right? So you all know about citizen science, and I think Mookie out of UCL is taking a very, very strong leadership role in what he calls extreme citizen science, and he has come up with how different people are contributing at a different level, from anywhere from one crowdsourcing to extreme citizen, where people are actually smarter than you and I in terms of doing science. They are not card-bearing or credible. And we have all kinds of people doing that. What I found was very interesting is this experiment that they're running around the Heathrow about just the residents collecting noise data for airplanes for the scientists to actually understand what is the challenge. It's a big challenge in Chicago, I know, for FAA. The next thing Mookie showed me is that what you can do in Central Republic of Congo and everywhere else in Africa, where these people are using a smartphone with a picture-driven menu, and they're reporting locations of poachers and carcasses and tents and fires and guns, and they are owning their own resources about trees and animals and all that stuff. So, I'm a smart guy, right? So I said, oh, cell phone. So how are you going to charge that cell phone in the Democratic Republic of Congo in this kind of an environment? And he showed me this Japanese technology that is now allowing you to plug in your cell phone as you are boiling water for an hour. It will charge that phone 60%. You can buy it at REI now. If you go to the REI store, they are selling these things, right? So it's amazing. So as a nation, we have come a long way. You go to NOAA or USGS. NOAA now says they have 60 formal projects where they're using crowdsource and citizen science, formally accepted. USGS has long been part of this. They had a volunteered mapping core. And recently, you probably have all seen this report where they now have included Twitter in their earthquake prediction, because what they realized is that the S wave, that is the lagging one, travels slower than the tweets. So by the time their seismograms are detecting the X waves and doing all the calculations and sending out the broadcast, the tweets are already out there. And that's what the data shows, that you could only go, this is the extent that the S wave have traveled, but all this area outside, all the tweets are already telling them that there was an earthquake right here. So it is changing science the way we have always tried to do, we have done science. I was interested in, we do population dynamics, so we were interested in, how, when people move, can you track with these kind of big data sets? is crowdsourcing a strategy, active or passive? And there are examples of how back in when Italy won the World Cup, several World Cups back, how they tracked the cell phones, and as the crowd moved from the airport to the city center in Rome, and then there were questions about privacy and anonymity and all that. That's what the key core thing that comes and bites you, right? So self-disclosure is a very core phenomena in social networking. We all do that in part, knowingly or unknowingly, right? We tell people where we are and what we are doing. You may not be the only one, okay? I'll give you another litmus test, and so maybe this is a good time. How many people are concerned about privacy? Okay, and of those of you who raised your hand, how many people are actively taking measures to protect your privacy? Okay, so all the hands that went up, this is the questions to them. If you have an online bank account, or if you do not have an online bank account, or an internet-based email, raise your hand. You do not have a Gmail. You do. You do not have a Gmail, Yahoo. All right. So you do not really have privacy. Your expectation of privacy is very falsified. You are concerned, but you don't really have. You are using it very smartly because you are incentivized to do it. So we are driven by incentives, and that's what I'm going to tell you now. So in few years back, we were having this thing about, all these caps were coming out about self-disclosure of where I am. And we had a meeting at ESRI about emergency response, and we had a long debate saying, will there be any time when I would like to self-disclose my location voluntarily? What would be my incentive? Right? Under what incentive I will do it? And we looked at things like, is this going to be a service? What am I going to go and get in return? Right? And we almost felt like this is not going to happen. It seems very strange. But guess what? The Boston Marathon bombing was a tipping point in our history because that event essentially lowered that public surveillance or surveillance in public places, acceptance of that fact for the American public changed on that day. Okay? The other thing that happened is that these kind of services became extremely popular because you cannot call anybody, but you can send that small packet showing that this is where I am, and everybody in your family knows that you are okay because you just put a dot on that map. So I have this because now we have 3 boys, and all of them have phones, so we have as a family signed up for it under protest from them, but we still have, and we have an agreement, but it is an incredible tool. I will do it. The movie theater is another one that if I go into a space for the next 2 hours, I am willing to disclose my locations provided you know where I am and I'm going to get some service, right? It's only going to come back. And there are many that is coming, okay? I'm just giving you one example. There is another one. This is another very intriguing thing that I'm being, so the Arab Spring brought everything, right? And then there was the London riots, which showed that how these rioters were moving from one platform. So they were moving from iPhone to BlackBerry. Once the authorities were jamming one channel, they would move to another, It's fascinating. But what comes up in this debate is that, are we infringing on individual rights and freedom, right? Is this a democratic process? Am I going into democratic, rights by not letting people controlling how they can do it? And I was in terms of favor of this thing, saying, no, you should not, the government should stay out of this altogether, till I was in India in 2013, I believe. And there was a small incident in the northeast part of India where some people from the southern part were beaten up, or there was some violent, there was some scuffle. And the whole country was under this rumor that people from the northeast region are going to be targeted everywhere else, right? And it got elevated to the level that the government had to put 3 special trains a day to get people out from other parts going back to the northeast. And that's one of those pictures. So people are more likely to die from stampede than from actually being attacked by somebody else, right? How did I find out? Is because I am texting all my friends and I'm getting 0 answers. And I call them and I blast them saying, why won't you answer my text? And they said, what text? And I said, I sent you like 5 texts. And they said, didn't you realize that we are only limited to 5 a day now? Or today, we can only send 5. And I said, why? He said, because that's how the rumor is spreading, by people forwarding these text messages, right? When I looked at what the model is, it is exactly the same network model that we use to intervene into influenza and school kids. When influenza breaks out, parents have to go to school, they send these 6 kids to school, and it starts propagating. What do? We close schools. We break that chain. We close schools, and we create that buffer. It's the exact same model, okay? So not always maybe it is of this thing. Empowering individual citizens, you may be familiar with this. This kid got lost, adopted out of the streets of Calcutta when he was like 5 or less, and then 20 years later he used Google Earth to track back his mother in back calculating, reverse engineering. But I want to give you one example from my own life, and this is what I like to do it. So on that same trip in India, I'm sitting, drinking my coffee in the morning, and I get this email that said, your account has something is going on. We have locked your credit card, right? So growing up in a national lab, what do? I immediately delete that email thinking, oh, it's a spam, right? It's a phishing exercise, so don't believe it. But then I said, okay, I'm going to log in to my account and see if it's true. And I log in, and sure enough, there is in red, it says, you got to call us back because we suspect fraud. So I call, and then the gentleman says the exact same routine, like, we would like to go over a few charges. Can you verify those charges? And the first one was $1 to Google. And I said, no, I have no idea about, but I said, look, my wife is, across the world, so, sometimes you check out, and they will say, do you want donate $1 to, like, children's hospitals or something like that? And I said, they may have done it. And says, okay, how about $141.45 to Verizon Wireless? And I said, oh, I know that number because that's my monthly bill every month. I know that number. That's a valid, legitimate charge. And then he said, how about $29.95 to a Christian dating site? And I said, it's surely not me, and I hope it's not my wife. And I said, okay, so can you tell me when did that happen? And they said, yeah, at 2:58 p.m., at 2:52 p.m. In the afternoon yesterday. And I said, that sounds crazy because she put a picture on Facebook at 3 o'clock from the movie theater with the kids because she was watching this movie. And the guy said she would be right because at 2:58, we declined her charge from Regal Cinemas in Knoxville. I felt empowered by that power of big data. Okay? That's how it should work for individuals. I know Xiaowen is getting... here are some questions that I put that I do not know whether their answer is. If you watch the trends in the US, one of the disturbing trends is how much our calorie intake has gone up for no reason. We don't need it, but we are eating more and more and more calorie. What is the biggest challenge for us as a society? Obesity, right? So is there an equivalent for data? How much more information do we need, and is that going to create a bigger challenge down the road that we do not know about. It's not a level playing field because the private sector holds most of the data that is transactional. And they're creating very, very powerful things that is going to make the government functions obsolete, like agricultural extensions being one. There is a distinct change in terms of, although we are concerned about privacy, but our sensitivity to sharing data sets or sharing our lives. If you read up, you will see that the hotel industry is up in arms against this Airbnb. Last year, Intercontinental sold 151 million hotel nights. Airbnb sold 100 million. This is people like you and me who are basically letting other people come and stay in the room that they never use. They're empty nesters or something. It is an incredibly social revolution that's going on. So people, although we would like to believe that we are very private and nobody wants to share data, we are sharing data all the time. Okay? The grocery cards, how many people have grocery cards, grocery store cards? That they give you discount stuff, right? So they are doing things. Here is what I find extremely disturbing, my VIN number. BMV sells my VIN number to Polk in Michigan, and they collect all this BMV data, they clean it up, and then they license and sell it at an enormous amount to all the researchers about vehicles, right? I don't think I have an expectations of privacy when it comes to my cars. I do not know how to keep that a secret. If you know one, I would love to know about that how do you keep what car you own a secret from everybody else, right? The question is, why do I not part of that economy? All the data that people are using for this analysis actually originates from people like us. And I want a way to get involved in that. And that's where I think the crowdsourcing part comes, is that data actually resides distributed, but is there a way we can harvest that? There are lots of things that are associated with it, especially in social, legal, and ethical issues, which we do not know what the real right or wrong answers are, but what we know is that all these have variable standards. It is being driven by incentives and your willingness to accept that incentive at a particular situation. And it's working elegantly in a lot of applications. There is, from a federal standpoint or a research standpoint, one thing that I feel is a big gap is we do not have a very good coordinated national strategy for curating these kind of data sets. This is one of our summer interns who sent me these pictures and videos from Sandy. So this is from his home. He lives in the Jersey, Pennsylvania coast. And he sent me these pictures and videos and just like that. And I'm thinking there's so much information about the consequences and impact and everything else, but we have no concerted strategy for keeping and curating these data sets. All right. I think I'm going to stop here. The social dimension is important. We all have a cell phone provider who provide an application for stopping you from texting if you're driving faster than certain speed limit, okay? How many people know that your provider has a free app for that? They don't tell you because they want you to text, right? But that is, if you ask somebody, they will say, the texting and driving is the biggest challenge, right? So there are ways we can all make a difference out there. This is my favorite, and the last slide is, I saw that, when it comes to texting, that this bumper sticker, it said, honk if you love Jesus and text if you want to meet him. I thought it was fantastic. Okay, I'll end there. And I know that I ran over a little bit, but that's all I got to tell you today. Thank you. Thanks for your attention.
Running a little questions, move closer to microphone and use microphone to pose your questions.
Yeah, I'm very interested in this problem of the curation of data. So, what do you propose?
We need an effort that is outside the private sector, in between the private sector and the federal government. The federal government doesn't want to touch it because they don't want to get involved in the PII issue. They don't have a good understanding of what to do it, so they will not just touch it. The private sector, of course, holds everything now, and then it's only a one-way street. And I think that's where I have been firmly believing that the R&D, research, science and research community can create across labs and academia together is this mechanism by which we can maintain these data sets without the challenges that Twitter has now created. And I was telling Shawan last night that if you read just the headline that Twitter has opened up its entire archive for science and research, you feel like your heart warms up till you read the fine prints. So 15th March was the deadline, and there is an article in Science, if you read that. I do not know which scientist is going to sign up for it. I'm curious to see who actually does. So I wish I had a better refined answer, but I think that's where it needs to be.
One more question, maybe, from the audience? I saw some students in the audience, so I'm going to ask one question.
Sure.
In this very rapidly evolving space of science and technology, what would be your advice to the next generation as to what they need to jump into for their knowledge structure, gaining the elements of knowledge to be contributors for solving the problems you shared with us today? I know you are actually in the federal agency space a major employer expecting talent out of universities.
That's a great question. One of the things that we are encouraging all our academic colleagues and their students to actively think about is this issue about changing way of variable standards in data. Even if you think about the federal practicing community, one of the things that is slowly but steadily coming into play is fit for purpose is what really the term people use. But essentially what they're saying is that, look, for the longest time, we have created data with a very top-down standards measure put on those. Like it has to be 80% accurate. And that's why it takes like 3 days to get the flood maps after a hurricane, right? And at the time when it comes out, it is of little utility. But the question is, do you really need 80% accurate data to make the difference out there, right? Bringing that kind of thought process into our workforce is very important. That how do you, with certain level of confidence, make those kind of changes in the actual workflow that goes on? I can give you one example where one of the FEMA employees shared with me that saying the best way to understand what people are looking for is to browse Craigslist. But if you go and you see the FEMA manuals, I want to know where in that workflow is that step. It doesn't exist because we cannot quite defend it, right? It has to be authoritative and defendable in space. But we all agree that it's more important to make the difference and the impact than get hung up on whether the science was accurate. But again, the science standards. So I think the next generation is getting a lot better at understanding because they're growing up with it, they're living with it. And so where the boundaries are between what we call traditional scientific data versus what is coming from other places, that's the training I think is going to eventually help us.
Thank you. I think we need to conclude, and let's thank Bhaduri.
Oh, thank you.